without you. You're so defeated. Without you, your mind full of tears. Without you, trying to have a good time. Without you, waiting for auditions. Well, I hope you're feeling good. Yes, I hope you're feeling good. Yes, I hope you're feeling good. Without you, look across the ocean. Without you.
All right, hi there. Today, I'm going to be looking at absolute value equations and inequalities for that matter when you put them both together. So let me start off with a couple of basics, just a quick refresher. What is absolute value? Absolute value is defined as the distance between the number and zero on a number line. So, you're kind of making these things positive. If I took the absolute value of -6, that would be +6. If I took the absolute value of +6, that's also 6. Don't change it to negative. All right. Now the idea is when I have an absolute value of a variable, there's actually two answers that I can plug in there, right? If I told you the absolute value of this was 4, that would mean x could be two things. It could be 4 or it could be -4. So it's got two answers for that. So that's the basics of absolute value. All right. So with that said, going back over here, if I had the first one I got is the absolute value of 2x minus 1 equals 5. There's the idea of whatever's here inside that absolute value sign is going to be one of two things. It's either 5 or -5. So, we're going to break this up into case 1 and case 2. Case 1 will be the positive answer. Case 2 will be the negative answer. So it's either 5 or it's -5, the positive or the negative. Change those to plus and minus. Case 1 is the plus, case 2 is the negative. But now what's going to be equal to 5 is the 2x minus 1 on both of them. So those are my two equations that I'm now going to solve. Draw a line down the middle, solve them separately, and we'll get my two answers. I got 2x equals 6, divide by 2, and quickly get your answer of x equals 3. And the second one, it'll be if I add 1 to both sides, I get 2x equals -4, divide by 2, and you get x equals -2. So there's my two answers. I got -2 and 3, and that's it. Number 2, got the absolute value sign with a negative sign outside of it this time. X plus 3 equals 6. Okay, now the first thing I like to do with these is to get the absolute value and what's inside of it all alone on one side of the equal sign, which means I'd like to get rid of this minus sign. So I'm going to actually multiply by -1 both sides. Oops, you could divide by -1 also, but I'm going to multiply by it. And what happens then is those cancel out. And I'm left with the absolute value of x plus 3 equals -6. Which brings up an interesting predicament, because I'm looking at this and I've got the absolute value of something, in this case it's x plus 3, equaling a negative number. Now, if we take a closer look at that, the absolute value of something in here, I'll just call it y, there's two things you'd fit in there for y, either 6 or -6, but neither one works. The absolute value of 6 is 6, and the absolute value of -6 is also 6, which means there's absolutely nothing that you can plug in there for y and get a negative answer, which means anytime you've got the absolute value of something over there like that, absolute value of something equaling a negative number, there's no solution. If you wanted to take that a little more in depth and talk about how the definition of an absolute value is the distance between the number and a number line, and the distance is -6, there's no such thing as negative distance, all right, on a number line anyway. So that's the answer, no solution. Number 3, solve and graph the solution. And the equation is 3 times the absolute value of x plus 2 minus 1 equals 8. Okay, so this one. Once again, the idea is to get that absolute value sign and what's inside of it all alone. So I want to get that alone. So the first thing I'm going to do is add 1. Those will cancel. Then I'm left with 3 times the absolute value of x plus 2 equals 9. Now, you really don't want to go doing distributive property with absolute value signs. In this case, I don't think it would actually make a difference because the 3 is positive. However, if that 3 was negative, you would absolutely get the wrong answer. So don't do distributive property with the absolute value sign, all right? Really, it's I've seen it done a couple times, but it's risky business. So those cancel out. I'm dividing by 3 because that was the opposite of the multiplying by 3, which was connecting the 3 and the x plus 2, which now leaves me with absolute value of x plus 2. 9 divided by 3 is 3. All right, now I've got the absolute value all alone. Now I can break it up into case 1 and case 2. Case 1 will be the plus, case 2 will be the minus. So I got x plus 2 equals 3. Over here I got x plus 2 equals negative 3. And I'm going to draw a line down the middle, solve my 2 equations, and get my 2 answers. 3 minus 2 is 1. Negative 3 minus 2 is negative 5. So when they say graph the solution, this is not going to be a 4-quadrant graph. This is just putting them on a number line. You know, here's negative 5, here's 0, here's 1. Notice how I spent so much time on that number line making it and labeling every single number. All right, so I got two solutions here. X can be negative 5 and x can be 1. And those are my two numbers, okay? And you just put the dots there. That's it. All right, next one, number 3. Sorry, number 4. This one can be absolute value, okay, and an inequality. Absolute value of 2x minus 1 is less than 5. Okay, so this one, when I have an absolute value and an inequality, I'm still going to, and I've already got the absolute value and what's inside of it alone, I'm going to go straight to the case 1 and the case 2, okay? So case 1 is the plus, case 2 is the negative. All right, now what I get is I get 2x minus 1 is less than 5. There's the positive, that one's easy, stays the same. The negative is going to be a little different than what you'd think. I'm putting the negative 5 over here. However, this time when I do the negative case, you got to flip the sign the other direction. This is kind of tricky. Let me write the directions here. When doing case 2, the negative of an absolute value inequality. It's only when you have the absolute value and the inequality. Flip the sign. Okay, when I say sign, that means, the greater than or less than symbol, okay? All right, so the reason why that is the way it is, let me just quickly go over this. Say I have the absolute value of x, this would be a sidebar, is greater than, let's just say 2, all right? Now, there's a bunch of numbers here, and if I look at this from a number line point of view, here's 2, right? Here's 3, here's 4. There's a lot of numbers over here that are greater than 2. And if I take the absolute value of them, it stays the same, right? Absolute value of 3 is 3. Absolute value of 4 is 4, which means all those numbers are solutions to this. Now, here's where it gets kind of funny, because if I took negative 3 and took the absolute value of it, I get positive 3, which is also greater than 2. All right, so that's also a solution over here. In fact, everything beyond negative 2 is also a solution. So you get all those answers that are, on the greater than it, and then they're also less than it. Because remember, the farther to the left on the number line you go, it's also less than. All right. So anyway, that's why you have to flip the negative, flip the sign on the negative value. So let me draw a line down the middle. I'm going to solve these two now, okay? And then I'll even graph the solution. All right. So if I add 1, I get 2x is less than 6. Divide by 2. I get x is less than 3. On the right, if I add 1, I get 2x is greater than negative 5 plus 1 is negative 4. Divide by 2. I'm dividing by 2, so I'm not going to flip that sign. If I was dividing by a negative, remember that's one of the laws of inequalities. When you're solving it and you divide by a negative number, you got to flip the arrow from greater than to less than, or vice versa. This one you're not, though. You're dividing by 2, not negative 2. Or not negative 4. Okay, so I got this. Now what I'm going to do is graph this. I'll graph the solution. Sometimes the directions say 2 and sometimes they don't. Here's negative 2. Here's 3. Notice how much time I spent making that number line. These are going to be open dots because there's no line underneath it. It's not the or equal to variety. And if x is less than 3, that's going this way. And if x is greater than negative 2, that's going this way. So the arrows are going to meet in the middle. So it's really everything in between those two is the solution, and that's what your graphed solution would look like. Okay? All right, so that was number 4. Number 5, I got the absolute value of 3x minus 4 is less than or equal to 8. Okay, so I'm going to do this one, and you guys we'll do a you try after that, and we'll see how you do. All right, so I'm going straight to case 1 and case 2. Case 1 is the plus, case 2 is the minus. All right, so I got 3x minus 4 is less than or equal to 8. Case 1 doesn't change. Case 2 does change. 3x minus 4, this is the negative. And remember, here's where I got to flip the sign here. I'm even going to change the color to red so it sticks out. Notice how I made that, change the arrow the other direction. All right, now let's draw a line down the middle, and we can solve it. Add 4 to both sides. 8 plus 4 is 12. I got 3x is greater than 12. Divide by 3. I get x is less than or equal to 4. The right side, add 4 to both sides. I got 3x is greater than or equal to negative 4. Divide by 3. And I get x is greater than or equal to negative 4 divided by 3 is negative 4 over 3. Don't make it harder than it is. All right, so if I'm going to graph this on a number line, here's negative 4/3. I'll say 0's here, and 4 can be over there. They're both solid dots because they have the or equal to underneath it. So remember, if it's one of these two, solid dot. If it's one of these two, it's open dot. All right. And let's see. Less than 4, that's this way. Greater than or equal to negative 4/3 is this way. So they're going to meet in the middle. So I'm going to connect the dots. There we go. And that's the answer. And it's graphed. All right. Here's number 6. You guys tried number 6. We'll do a you try. So you should try this on your own. It'll say solve and graph the solution. And the equation or inequality is 2x plus 4 is greater than or equal to 6. Okay, so you try that one, and I'll come back, hit pause, and come back in a minute. Okay, welcome back. So, quickly buzzing through this. Case 1, case 2, I get 2x plus 4 is greater than or equal to 6. Case 2 is 2x plus 4. Flip the sign, negative 6. Solve this. Subtract 4. You get 2x greater than or equal to 2. X is greater than or equal to 1. Over here, I get 2x is less than or equal to negative 10. Negative 10 divided by 2 is 5. Graph it on our number line. Here's negative 5. Here's 1. All right, let's see. Both solid dots. X is greater than 1 or equal to 1. That's that direction. Less than or equal to negative 5. That's that way. Remember, less than is to the left on the number line always. All right, and that was number 5. Number 6. Write an inequality for 6 less than a number is at least 5. All right, so this one, you're going to write the inequality, right? 6 less than, that's where you subtract 6 from something. We'll say n is the number, okay? So n minus 6, that's for 6 less than a number, is at least 5. So at least means it could be greater than, or it could be equal to it. So I believe that is what we got there. So there's that answer. Okay, here comes number 8. The quotient of a number and 8 is at most negative 4. Okay, so I'm going to write an inequality for this. Quotient, that means division. I usually use a fraction bar. And the order with division is important. So it says a number is first and then 8 is second. So the number that goes first goes into the numerator. The number that came second goes in the denominator. And it says at most, which means it is going to be, this is going to be, it can't be greater than 4 at most, so it's going to be less than. So it's got to be less than or equal to. You can make it strong. Yeah, at most would be or equal to. At most, negative 4. Yep, all right. And that's it. Number 9. Four x minus 3 plus x is less than or equal to x plus 7. Okay, so when I solve this, I like using the plus negative with this. It really makes, I make less mistakes. I get more points on tests is what I found. So I'm going to change that to, a plus negative. Now, there's an implied number in front of that parentheses, and it's a 1. So if I now take the negative 1 and I distribute it to both of those numbers, I will get the correct answer. All right, so I got this. Let me combine some like terms. 4x minus 1x is 3x minus 3. Now I can go right through solving it. I'm going to add, subtract x from both sides first. 3x minus 1x is 2x minus 3. Next I can add 3. And I get 2x is less than or equal to 10. Divide by 2. And I get x is less than or equal to 5. And there's your solution. Okay? Let's see, that was 9. This is an interesting one. You don't see these very often. All right, so I got, absolute value, negative sign inside the absolute value sign. So I'm just going to break it up and do case 1, case 2. If that was negative 12, that'd be different. It's okay to have that negative sign inside the absolute value there. Case 1 is the plus, case 2 is the negative. So I got negative 2x equals 12, and negative 2x equals negative 12. All right, so when I divide this out, I divide by negative 2. And I get x equals negative 6. Divide by negative 2 over here. And I get x equals 6 there. So those both came out kind of the way you'd think. Actually didn't change anything. It just changed which sign was on which side of the answer. All right, anyway. 11. I got a bunch today. I got 2 more. 4 times the quantity y plus 1 in absolute value equals 24. All right, so once again, I want to get the absolute value and what's inside of it all alone. So I'm going to divide by 4, and I got the absolute value of y plus 1 equals 24 divided by 4 is 6. Okay, now I'm going to break it up into case 1, case 2. Case 1 is the plus, case 2 is the negative. Don't have to change anything, they're just equal to y plus 1 equals 6, y plus 1 equals negative 6, and solve my 2 equations. And when you subtract 1, you quickly get y equals 5, and subtract 1, you get y equals negative 7. And those are the answers. All right, so here's my last problem. Number 12. Absolute value of 3x plus 2 equals 4x plus 5. All right, so here we go. This one's kind of weird because it's got variables on both sides. So I've got the absolute value alone. What I'm going to do is I'm going to break this up, okay? I'm going to break it up into case 1 and case 2. Case 1 will be the plus, case 2 will be the minus. So what I get is I get 3x plus 2 equals 4x plus 5. Case 2, I got to use parentheses on that right side. Let me move that. Because this is the negative 4x plus 5. All right, so that'll give me my 2 answers. The only thing that really was different there is I had to use parentheses around that whole thing because you're making the whole answer negative. All right, now let me solve it. Subtract 3x. I get 2 equals x plus 5. Subtract 5. I get x equals negative 3. And over here, if I go do the negative out, I'm going to make that 4x negative and the 5. You're distributing that negative sign. Now I can add 4x to both sides, and I get 7x plus 2 equals negative 5. And subtract 2 from both sides, I get 7x equals negative 7, divide by 7. And I get x equals negative 1. So I got two answers here. Now, it's good to double check these ones, all right? Because some funny things happen when you got those variables on both sides like that. So let me just rewrite this equation for 1 minute. I got the absolute value of 3x plus 2 equals 4x plus 5. All right, now inside I put I'm going to use the negative 3 first, okay? So I got 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. Okay, and what do I get when I do that? This is just checking my solution here. 3 times negative 3 is negative 9. Negative 9 plus 2 is negative 7. Negative 4 times negative 3 is negative 12. Negative 12 plus 5 is negative 7. So this actually doesn't work because the absolute value of negative 7 is 7, and 7 doesn't equal negative 7. So you're actually going to throw that one out, okay? If I check the negative 1 one, what do I get there? 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1 equals negative 4 plus 5 is 1. So I get 1 equals 1. So this one works. There's only one solution. Okay, is what happens with that one. Anyway, I know that's a bit of a weird one, but that's what happens there. All right, so that's what I got for today. I'm going to close it out with a little more music.